So on to problem number 18 of the MIT Integration B qualifying exam 2014. This is actually quite an interesting problem, right? The definite integral from x equals to 0 to x equals to 1 of 1 over the floor function of 1 minus log to the base 2 of 1 minus x. Quite intimidating, but actually it's a very simple problem. Let's see how we may be able to solve this problem. So this is our problem, right? The integral from x equals to 0 to 1, or 1 over the floor function of 1 minus log 2 of 1 minus x, right? The question is, what is a floor function? Right? So if you have a floor function x, for example, this is equals to k in the for that x is let me write it properly. In the interval x is greater or equal to k and less than k plus 1. And that also applies for a function fx. Within that, it's equal to k in the interval fx is between k and k plus 1. So surprisingly, this is in the denominator where we really need to focus. The floor function is the denominator. So let's see how we may be able to attack it, right? So we want to see a situation we are focusing on the denominator where log to the 1 minus log to the base 2 minus x equals to k. This happens when 1 minus log 2 minus x is less than k plus 1 but greater or equal than k. So that means that k minus 1 I've subtracted 1 from both limits. And then one crucial thing here is we could also express these because I've decided to take that power off to the other side. So we have k minus 1, we have log 2, 1 over 1 minus x. Okay, so this also means 2 right? And furthermore, we could now take the reciprocal such that 1 over 2k minus 1 is greater or equal than 1 minus x greater or equal to 1 over. Right? As we continue, we can now subtract 1 on both sides. So we have 1 over minus 1 is greater or equal than negative x greater than 1 over 2 to the k minus 1. Remove the negative, so we have 1 minus 1 over 2 k minus 1 1 So in that interval is when um, the floor function of 1 minus log to the base 2 of 1 minus x is equal to k, right? So we've come to a very good spot where we have in the interval 1 minus. Okay, so what that means, when k equals to 0, for example, we have 1 minus 1 over 2 to the power negative 1, 1 minus, which means we have negative 1, because this is 1, so 0 in this interval, which is already out of our integration band. So we are not going to deal with when k equals to 0. So what about when k equals to 1? That means 1 minus 1 x 1 minus a half. So in other words, from 0 to a half, and in that region we have 1 log to 1 minus x, floor function equals to 1, because equals to k, and therefore the fraction of the floor function 1 minus log to 1 minus x equals to still 1. In other words, so that is valid. Okay, when k equals to 2, when k equals to 2, we have 1 minus 1 over 2, 2 minus 1, 1 minus, okay, which means we have from 2, this is a quarter, so 3/4. In that regime, 1 minus log 2 1 minus x is equals to 1 over 2. Okay, and then when k equals to 3, we have, you can go and prove it out, but we have x so 1 minus eighth, so, and in that interval equals to 1 over 3. Okay, so this is very, very, very interesting, and we're coming now to a generalization step where we have, right, from 0 to 1, and we've seen that up to a half we have 1, right? So it's constant. That's our integration. Okay, then up to 3/4, we found that at that point is 1 over 2, so a half. Then up to 7 over 8, we have 1 over 3. So in other words, our integral from 0 to 1 of the floor function of 1 minus log 2 1 minus x is equals to the summation from k equals to 1 to infinity of, this is a rectangle, so one rectangle, and we see that the width of our rectangle is going to be 1 over 2 to the power k, and then the height is 1 over k, so that this part here moves discretely 1 over k, 1 over 1, 1 over 2, 1 over 3, 1 over 4, like that. So this is our problem, and so our integral has become a summation problem from k equals to 1 to 1 over 2 to the power k times 1 over k. I like to express it in the format such that it's 1 over 2 over k. We all know that Taylor expansion of the natural log of 1 plus x is equals to x minus x squared over 2 plus x cubed over 3 minus x to the power 4 over 4, and so on. But then log of 1 minus x, natural log of 1 minus x, is the same as x, negative x minus x squared over 2 minus x cubed over 3 minus x over 4. Because now so this is what it becomes. And so negative log of 1 minus x is the same as x plus x squared over 2 plus x over 3 plus x over 4 over 4, such that our summation of k can be the same as negative natural logarithm of, in place of a half, in place of x we now have a half, right? Which is equals to negative, because essentially what we've now substituted, this is the same as this, but with x being half. So this is a half, and then when we take the negative up here, we get log 2. So what that tells us that our integral from x equals to 1, 0 to 1 of 1 over the floor function of 1 minus log to the base 2 or 1 minus x is natural logarithm of 2. And that is our answer. I hope you did enjoy following along. If you have any question, please feel free to reach out. This is actually a very interesting problem. But until next time, bye-bye.